Yo everyone, welcome back to another tutorial. This one's for loops. We'll be going through the for loop, just a generic for I equals some value, which is the starting value, to the finish value by this amount of steps, or this increment. And we'll go through the repeat loop, and we'll go through the while loop. Now, there is other types of for loops, which is the I pairs and pairs, but that's for tables, so I'll keep that separate and put in a different video which is called table manipulations, and that's available on the channel already. Go look at that one if you want to see what that is. I'll also refer to that. I'll probably change the name of that video to fit in this tutorial series, so it's in the correct spot, but that won't be till later, so yeah, we'll get back to that. So, for our first one, we have this loop here. We have for I equals some start value to the finish value, stepping by this amount, and we'll have a code block in here. So this is basically saying for I is equal to some starting value. I want to reach the goal, and I want to reach the goal by adding this much every time, and then we can actually run code for every step of the way. So if I say for I is 0, the finish is 1, so we're going to start from 0 and we're going to reach 1. If I don't add the step here, it's going to automatically do positive 1. But I want to add a step, and I'm going to say make it 0.1. Now I'm saying for I equals 0, repeat adding 0.1 until we reach 1. So if I print I, it should say 0, 0 plus 0.1, 0 plus 0.1 plus 0.1, so it's going to say 0, 0.1, 0.2, 0.3, 0.4, all the way up to 1. So if I run that, you'll see there's some floating point errors, which is these large numbers here, but it starts from 0, it goes 0, 0.1, 0.2, 0.3, 0.4, all the way up to 0.999 recursive, which is 1. And we can do the same things in these ones, but it's a little bit different way of doing it. But there's one there, so that's starting from 0, going to 1, incrementing 0.1 steps, or incrementing by 0.1 until we reach the goal. And we can do descending also. So if we start from 1 and we want to reach 0, we can't use 0.1 because that's not going to work. We're trying to add to it, but we want to negate from it to reach 0. So if I do negative 0.1 this time, you see it will start from 1 and count down towards 0. Now, you may think at first this number is bigger than 0, or bigger than 0.1 even, but because of this e to the negative 16 here, that's saying it's a very small number. It's got minus 16 decimal places, which is 0.3, 6, 9, 12, 15, 16, 1, 3, 8, 7, 1, 3. So it sort of looks like that. That's the number that it gave us. But if we round it, it's 0, basically. So we don't have to worry about that. So there's our basic for loop there. Now we've got a while condition loop, which is while the condition is true, do this code block. So we can't really test this one. We'll do the same thing as a for loop here, where we start a number, finish a number, incrementing this amount. But this one's more applicable in actual like game coding, where you need to like animate maybe some UI or something, or you need to check whether or not a certain state is true. So like I could say while not player data do task.wait1, so that's going to yield until there is player data, which is this variable here. So something like that we can use in actual games, but it's more harder to test it by itself. We can do something like local number equals 0, while number is smaller than 1, do number. There's two ways you can add to it. You can do plus equals 1 or number equals number plus 1. Depends your use case, but For this time, we are only adding the number to it, so we can just do that. But yeah, so this is basically saying while our number is smaller than 1, do add 1. Let me actually change it to 0.1, and we'll print number after we add to it. So we start at 0, we add 0.1 every step of the way, and we end up with 1.1. So the reason for that is because we have this smaller than 1. We don't have smaller or equal to 1. Now if we try that, it should finish at 1. Oh, it still doesn't. Oh, and also that's because we increment... Oh no, it's the rounding error, that's why it's doing it. So actually what we can do is number equals number plus 0.1, and then we can call math.round on that. And if we do that, that should fix it hopefully. Oh, sorry, this rounds it to the decimal. So that script timeout setting, it's gonna stop it for us, hopefully. No, okay. So the problem is that we rounded the decimals out, but we're incrementing by decimals, so it's staying at 0 and it's never gonna reach 1. So what we actually needed to do was, yeah, let me take Notepad real quick. So we're going from 0 to 1 by adding these numbers here. What we just did was we floored it, or we rounded it, so that means if it's 0.1, it rounds to 0. If it's something like 0.6 or 0.5, because it's past a halfway mark, or is a halfway mark, it'll round up to 1. However, we want to round the decimal place itself. So what we want to do for this is, so let's say this is 0, that's 0.1, 6, 0.7, 0.8. We want to times it by 10. So when we times it by 10, it becomes 1. We want to round that and then divide it by 10 again. So now it's back to 0.1. The reason why we do this is if we have something like this, let's say. If we times it by 10, we get 1.3253. And then we round off those numbers. And then we divide it by 10 again. So now it becomes 0.1. So that's what we're going to do, but I just kind of did it without times it by 10. So if we increment it by 0.1, we times it by 10, round it, so we get rid of the decimals, and then we divide by 10 again, it should give us our number back. There we go. So we're going from 0.1 all the way up to 1, and then we'll also get an extra step at the end there. While it is smaller than 1. So if we change that back to while it's smaller than 1, there we go. Now it finishes at 1. Because what we had before was if the number is smaller or equal to 1. So if it's equal to 1, we still increment it. But we only want to increment it if it's smaller than 1. But now we've also got rid of the round precision error, the floating point precision error, sorry. And now it's actually looking much better and we're getting the correct numbers. So that's the second loop there. So it's just pretty much while this condition is true, keep doing this code block over and over. That's the same for the repeat one. So let's do the same thing here. Local number equals 0. Repeat number incremented, and then we floor to the first decimal place. While number is smaller than 1. So in this case it says until the number, or until the condition. So in this case we want to say until number is larger or equal to 1. And then once that condition is true, it will stop. So if we print this in here now, we should have, that's the first loop there, then that's the second one. And it does the exact same thing, but it's in 2 different formats. So why would you want repeat loops, or why would you want while loops? Why aren't they, why aren't they just used wherever? And the reason for that is because the while loops condition is checked first, the repeats condition is checked after the code block. So while condition do, so it will immediately check the condition if it's true or not, and only if the condition is true, it will do the code block inside it. In the repeat one, it says repeat code block, so immediately do the code block until the condition is true, which in this case our number is larger or equal to 1. And the for loop is just pretty much the same thing here. For I equals 0, and then so local I equals 0, while I is smaller than step, or smaller than finish, or larger than finish, do I equals I minus 1 or I plus 1, whatever it is. And throughout the way, you do the code block. So that's pretty much what for loops are like. It's just like keep doing something until the condition is true. Keep incrementing this number until condition is true. Something like that. So we can do different applications of this. We'll check it out when we're doing games and all that. But yeah, it doesn't get much past this until you actually start practically applying it. So yeah, that's it for this one. I'll see you in the functions tutorial, which is next, and that is a very important one. So see you then.